Even small changes in one part of the planet can have effects felt all the way around the globe. The world's largest, hottest desert, the Sahara, is nearly the size of the continental United States. Each year, millions of tons of its nutrient-laden dust are swirled up into the atmosphere by easterly trade winds and carried across the Atlantic. The plumes can make their way from the African continent as far as the Amazon rainforest, where they fertilize the plant life of one of Earth's most biodiverse regions. The dust carries phosphorus, a nutrient necessary for plant growth. As it travels around the globe, the resultant layer of dust can easily be seen from space. This was especially true over the month of June 2020, when satellites and astronauts observed an unusually large quantity of dust, nicknamed the Godzilla plume, heading west from northern Africa. It thinned out over its 3,000-mile journey, depositing nutrients into the ocean and land below. To travel such a distance requires strong winds. These winds are from the trade wind system. The trade winds are affected by differences in sea surface temperature between the northern and southern Atlantic Ocean. Over the last century, the North Atlantic Ocean has experienced a shift in sea surface temperature every few decades, referred to as the Atlantic Multidecadal Oscillation, or the Atlantic Multidecadal Variability. Warmer sea surface temperatures in the north, like those observed in recent years, lower the contrast between north and south and change wind circulation, slowing the trade winds down. The northern and southern trade winds converge along a latitudinal band called the Intertropical Convergence Zone, or ITCZ, which is where rainfall is most concentrated in the region. The ITCZ encircles the globe, and its connection to sea surface temperature and wind has been supported by observations over thousands of years. Though the band of rain always moves north and south with the seasons, a recent NASA study shows that the ITCZ has been migrating farther and farther north over the last several decades, likely a result of the warming climate. As the band covers more of the Sahara, increased quantities of rainfall over the desert dampen down the dust, making it even less likely to be carried off by the already weakened winds. As the climate changes, dust activity will continue to be affected. NASA researchers predict that within the next century, we will see dust